Okay, sweet, it's recording. Cool. All right, yeah, so welcome back to the second tutorial. The first one was covering the basics of nflfastR. So this one is going to be going into like how to make some nice like data viz, like how to make some nice graphs and stuff like that. So we can get started here by loading in our packages. So the first one we always want to load in is the tidyverse package. It has basically all the functions that we're going to use today. And then on top of that, we're going to load in the nflfastR package, which has our data and like our team's colors and stuff like that. The GG image package, which will be used when we plot team logos. The GT table package for making nice tables and stuff like that. And then this one, if you if you just did the last tutorial, you might have to do install packages, GG themes, because we didn't install this package last tutorial. So if you haven't installed it yet, run that line. If not, if not, you can just load the GG themes. Oh, and let me I just sent the link in the chat for like the code that we're going to do today in case you need it. So we're good to go there. Okay, cool. So when we load in multiple years of nflfastR data, the package recommends that we use this future package. And like, we don't have to like install this package and load it in because we just need one thing from it. And we're not going to touch it for the rest of like what we do today. So we're just going to do future plan multi-session. So running this just makes it, quicker to load in multiple years of play-by-play data. Because then we're going to do play-by-play, the arrow, load play-by-play data. We're going to do from 2014 to 2020 today, just to play around with some different seasons and stuff like that. So so by running that future plan multi-session should load in a little bit faster and get us going. Is everyone good so far on that? Cool. Okay, so now the next thing we want to do while that's loading in is we can start to get the just the plays that have runs and passes. So like filtering out special teams and like weird penalties and stuff like that. So we can do filter pass equals 1 or rush equals 1, which is something we did last tutorial. And then now what we want to do is we want to make a graph that shows a team's pass rate over expected by each season and how that compares to the rest of the league. So what we can do for that is we can create a new data set called pass rate over expected _ season. Take the play-by-play run pass that we created up here where we filtered out the runs and the passes. And then we can group by possession team, so post team, and then season, and then pipe into a summarize where we do pass rate over expected equals their mean pass OE. So that's what the column name is. So like if you were to go down here, actually, if we were to do names play-by-play, we can see pass OE is like the pass rate over expected, like the chance that they have a chance to pass based on the down distance, yard line, all that stuff. And then if they pass, it's 1 minus the expected pass. If they run, it's negative of that. And then we can do na.rm equals t in case there are any NAs in there. So we'll just remove the NAs. So we want that to be true. And then we're going to want to left join the team's colors logos from the nflfastR package, which has all of that stuff, the team logos and their main colors and stuff like that. We have to do left join because Okay, sorry, I had to start the recording again because my computer ran out of space. So yeah, so far what we've done is we loaded the packages in, we loaded the play-by-play data, cleaned it just to get runs and passes, and then now we're getting the pass rate over expected for each season, for each team, from 2014 to 2020, or yeah, or I guess we can make this 2021 Reddit. So, okay, so yeah, loading the play-by-play data, left join, post team equals team abbreviation, because in teams colors logos, it's called the team like name is called team abbreviation, but in the play-by-play data, it's called post team. So that's why we wanna link those up, basically. And then, so then what we can do is we can just set up this like team variable, basically. So we can either use the equal sign or the arrow. And so like, let's just set it to Dallas for this purpose, just because I think Dallas has kind of been interesting this year with the way they've approached their offense. But the way we're setting this up is that we can change it. So we can set up one data set where we say this is the team's pass rate over expected. So we have this pass rate over expected season data set. And what we can do with that is we can filter where just the post team equals this team that we set right there. And then we want the rest of the league's pass rate over expected to make the other dots for comparison when we plot Dallas's. So we can do pass rate over expected season. Oops. Filter post team does not equal team, because we don't want that that team in there. We don't want their dot, because it could look like they have the same pass rate over expected as another team for each season or something like that. So now we can make the graph. Anyway, I'll open this just so we can see what it looks like. So yeah, so it has each team's pass rate over expected for each season from 2014 to 2021. And then it has all their logos and their colors and stuff like that. So that's what we want. Okay, so now we're gonna make a we're gonna jitter what the league dots are so far, just as reference when we actually plot the logo for each team. Okay. I need to X out of stuff here. Sorry about that. Okay, so now we can use this AES to plot like the x-axis and the y-axis. So the x-axis is season, y-axis is the pass rate over expected. And then we want to fill each dot with the team color. And then we can put the border of each dot with the second team color, just to make it look nice, basically. And then actually I'll put this up here. Then we can now we can mess around, now that we've done all the stuff that's inside the data set, because like these are all things inside of the league pass rate over expected. We can play around with some of the functions. So like shape equals 21 is usually the go-to. It's the one where it has like a main color and then like an outside color. And then on a jitter, since like it kind of like, it doesn't put them in a straight line, just because in case two dots are on top of each other, you want to control the width and you want to make it kind of narrow, just so it's easier to read. You can do size equals 4, just as something that I usually go to. It's like kind of just play around with it depending on the plot, and then that's how you get your jitter so far. So we can see what that looks like in the bottom right corner as we build on that. So yeah, so it's kind of ugly right now, but it's like it's each plot each dot plotted. So now we can add stuff on top of that. So now we want to do the line for the team that that we want to plot, like their pass rate over expected. So we can use the team data set this time, and we can do same thing: x equals season, y equals pass rate over expected, color equals team color or team color 2, doesn't matter. And then we want to make this line bigger than default, so we'll do size equals 2 outside of the AES, because 2 is not something in the data set. Like, these are all variables that are in there. Same thing for geom image. Do that, and then we want to set the image to be team logo ESPN, which is the go-to side of there. And then aspect ratio, we want it to be 16 divided by 9, which usually makes it look the nicest. And then our size of the image, we want it to be 0.06, because we don't want it to take up the whole thing. So since all these dots are like these random team colors right now, it wants what you have to do is you have to make sure that it knows the identity that these are hex colors that we're using. So it's like the C83 whatever is supposed to correspond to something. So you can do aesthetics equal fill and color inside of there. And then what we loaded in this GG themes package was so that we could add a nice theme to it, so that it didn't have like a gray background, and it's a little bit nicer. So there's like all these themes you can pick from. You can make it look like Excel or The Economist or something. I just use 538 just because I think it looks the nicest. And then we can add in a y-intercept line at 0, just to show what the league average pass rate over expected is. So as we open this up, we can see Dallas's pass rate over expected by season compared to the rest of the league. So if I'm looking at this, the one thing that I don't like is that these dots are really dark, and it's tougher to see Dallas's logo. So the good fix for that is to do alpha equals 0.2, or it's on a scale of 0.1. So however dark you want to make them, you can kind of just mess around with the values. And so now the dots show up lighter, and so it's a lot easier to see Dallas's pass rate over expected by season compared to the rest of the league. And like the good thing is you can see these dots, like you can tell this is Kansas City right here because it's like red with yellow outline. This is Buffalo because it's blue with red outline and stuff like that. And it makes it look nicer. We want to label each axis. So we want to label the x-axis as season, y-axis is pass rate over expected. And then for the title, so since we set this team variable right here, what we can do is we can use this paste 0 function. And so what it'll do is we put that team in every time, and then we say apostrophe s, so it'll be Dallas's pass rate over expected 2014 through 2021. Add a subtitle, other teams in the NFL shown or reference. And then we'll do scale x continuous, because we want every season to show up there. And then we'll make sure we have our breaks. So again, we can access the scales package without loading in the whole thing by doing that. So breaks equals scales : pretty breaks n equals 6. So open it up to see how it looks. And yeah, it's looking pretty good. It shows every season, which is good. But the only things are the access text didn't show up when we did our theme 538, and the title is off to the left, and the subtitle is off to the left when I like them to be centered. So we can go into theme to kind of modify this theme right here, right? So we can do plot.title equals element.text, because we want to mess with the text element basically. Set the size, make it bold, so we can do face equals bold, and then h just equals 0.5. We can do the same thing for the subtitle, set it to 14, h just equals 0.5. And then the years kind of show up small when we look at it, so we can mess with that using access.text, which is going to change with these numbers right here, because it's tough to see this 10 when we open up the graph full size. So why don't we set that to 13 and look at it again. So that's looking a lot better. That's like a lot closer to what we want as a final product. And there's other stuff you can mess around too, but we're going to move on to the next plot. So if you want to save this, just save it as like del pass rate over expected, PNG, width equals 15, height equals 10, DPI equals retina. Run that and it'll save to your computer. Good thing about this is we can plug in other teams and run it again, and it'll change the title for us, which is why we did the paste 0, and it'll change this thing. So we can look at the Chargers now and see that they were about average pass rate over expected until this season, and they've completely shot up. And then you can just keep plugging in different teams to there.
Paige, why don't you add a access title element text, because the
Oh yeah,
seasons and pass rate, like the access titles aren't showing up.
yeah. So access text is to mess with these like little numbers on the side, and then the access title is to mess with like where we label season and pass rate over expected. Yeah, thanks. Sorry, I forgot about that. Okay, so now what we can do is, if we just wanted to look at some, like now we only can look at one specific team. Like how about if we wanted to compare within divisions or something like that? So what we can do is we can set up a list, and we can say we want like the NFC North. So we'll do Green Bay, Minnesota, Detroit, Chicago. So we run that. Now we have our teams list. So these are the 4 teams we want. And then we can get the teams pass rate over expected. So we're going to take this pass rate expected season, which is this big data set right now with 257 rows, and we can filter just for the teams that we want. So teams pass rate over expected. Open that, and we can see it's just Chicago, Detroit, Green Bay, and Minnesota. So because we just want to compare NFC North. And so now we're going to make a bar plot showing the 4 different teams. So what we can do is we can put season on the x-axis, pass rate over expected on the y-axis. And inside each bar, we want to fill it with the team color. We want the border of the bar, which is the color argument, to be the team color, the team second color, so team color 2. Stat equals identity, like lets it know it's this type of bar plot. You would do different stuff for if it's like a stacked bar plot. This one's just like a straight up one. And then we can change the alpha a little bit just to make it a little bit lighter, put 0.9. And then we want to put the team logo on top of each bar. So we can say same thing as we just did, where AES image equals team logo ESPN. And we want to put it on top of the bar, not directly on the bar. So what we can do is we can change what we want the Y to be. Right now, Y is pass rate over expected. here we want to do, if it's a positive bar, we want to add 1 to it, and then if it's a negative bar, we want to subtract 1 for it. So like you'll be able to see when when we plot it here, like see there's some bars that are negative, so we would want the team logo down there, basically. So we can use an if else statement for that, and we can say if pass rate over expected is greater than 0, then add 1 to it. If not, subtract 1 to it. So this is the statement. This is if true, and then if false, basically. Again, do the aspect ratio and the size. Scale color identity, because it didn't pick up on the colors. As we can see on the right, we want to do both fill and color since we have 2 color arguments. And then we don't want all 4 teams stacked on top of each other, right? So we use this facet wrap to get the different teams. And so what this will do is it'll split up each post team. If you have 2 variables, you want to, like you want to create a grid, you would use facet grid, and then the first variable would go here, then the little squiggly thing, and then post team. So, but we just want to split it up by 1 right now. Team 538, as usual. Labs season, pass rate over expected. Y. Pass rate over expected in the NFC North, 2014 through 2020. And then, yeah, we don't need a subtitle. Again, we want to make sure each year is shown. So yeah, now we have our plot, which shows which has the team logo for each season. It has it has each bar. Again, like the same thing is like the titles off to the left. These team names look kind of small if someone was looking for them. I think it'd be hard to see. So there's stuff we can do to change that. So we can go into theme again to modify it. And then we want to, again, like last time, we want to change the title and make it bold. Oh, I guess we don't have a subtitle, so we don't need to do plot.subtitle. And then we want to do axis text again. We want to make that size 13 to make it easier to see. Axis.title, we want that to be slightly bigger than the axis text. So size equals 14. And then what we can do to make these team labels show up a little bit bigger is we can do, it's this thing called strip.text. And so here we would use the X ones because they're, they're facing the towards on the same thing as the x-axis. So if it's the other way, if you were to do post team squiggly, then it would be on the y-axis. And so we can set that to 14 too, just so it's easier to see. And then another thing I like to usually get rid of is the grids being the same direction as the bars, because those aren't really needed because the bar shows where each season is anyways. So how we can do that is we can do panel.grid.major. This one would be X because it's the x-axis bars. And we can just make it smaller just so it doesn't show up as profoundly and stuff like that. So yeah, so now this is the type of plot that I think looks a lot better. It has each season, it has the column names right, and then this is bigger now, so it's easier to see. So yeah, you would be able to save that with the GG save that we did earlier. NSC north, pass rate over expected, .png, width equals 15, height equals 10, DPI equals retina. So just like that. And that'll save to your computer. Anyone have any problems or questions with this graph? Okay, cool. So the next thing we can do is we can create a scatter plot now that we've done like a team logo jitter plot, a bar plot. Next step would be to create a scatter plot. So let's do it for quarterbacks. So we can do play-by-play passes because we just want the quarterbacks, and then since this is 2014 through 2020 all games, we just want to see the regular season basically. So we can filter just for quarterback dropbacks, get rid of all the plays that don't have EPA by doing !is.na, group by a passer, and then we want to mutate a total amount of passes. So usually we do summarize here, but this one, because we're going to do a scatter plot and a line plot, we're going to we want to get rid of some of the players that don't have that many passes. Like if they only have 50 passes since 2014 or something, we don't want them to cloud the graph. So when we do that group by, we'll mutate the amount of total passes. So that'll put a total passes variable into this big play-by-play data set, and then we'll ungroup. So we'll have the play-by-play again because we group by the passer, we ungroup, and then we want to filter, and we just want their career passes since 2014 to be greater than 200, basically. Oh, sorry, total passes. And so then we can start off with the line plot first, actually, since this one will be easier, and then we'll do scatter plot if we have time. So we want to do a cumulative EPA graph, right, showing their how their career has progressed, like who's had their ups and downs throughout their career, who's been steady. So we want their drop back number for each one. So like their first drop back, we want that to be labeled as 1, and we want it to be labeled as 2 for their second drop back, and so on. So what we can do is we can use this AVA function for that. And so what that's going to do is it's going to take our play-by-play data. We want it for each play that has EPA, and then we'll take we want to group by each passer, and then we can use fun, and we can use sequence along. So this fun could be like a lot of things. It could be like mean, or actually we can show okay, that ran. It's just giving a warning message. And so like this is another example of fun. So we want to do their cumulative sum. Oh, I see why. I did play passer there. There we go. Sorry about that. And then so this one we can do the cumulative sum. So sum like that, run that, and we're good to go. So now, I mean, if we were to open the data set, it's pretty big. It's 139,000 rows, but it'll have their drop back number and their cumulative EPA for each drop back as we go along. And so then, we could plot every single player's line, and it would be tough to get stuff from the data. So what we can do is we can highlight a couple players. So, if you think about like who has accumulated the most EPA since 2014, like it's Patrick Mahomes. So you can create like a separate data set just called Mahomes stats. And we can see if we were to like, if we were to just select and we were to say passer, drop back num. Like we can just see like how this data set's set up. So first 2 passes of his career led him into negative. EPA. Then he had some explosive plays, so it became 4.55. So we can see that in this line that we're about to create. And just for fun, we can also see how Josh Rosen did. So J. Rosen. Oh, sorry, passer equals. This part we're gonna have to hard code a little bit. We want to get their team colors for each one. So what we can do is we can say, since Mahomes plays whole career in Kansas City, Rosen started with the Dolphins. We can do those two teams, and then we can select. We're gonna want to put these colors into our line. So Kansas City's color and Miami's color. So we'll grab that in a second. So now we can create our plot. So we're gonna want to say we want the x-axis to be their dropback number, the y-axis to be their cumulative sum, and then we're going to want to group by passer. Since we never really did that here, because this is we're plotting a play-by-play set, basically, we're going to want to make sure each passer's line is connected. Make the color for the passers that we're not highlighting gray. Get rid of the standard errors by doing SC equals false. If you're doing like real statistical analysis, you're going to want to keep those, but this is just like a fun graph. And then we're going to want to do the same geom smooth, which will make a smooth line for Mahomes instead of like every passer. So we can do Mahomes stats, and then basically the same code, except instead of color equals gray, we're going to want to go down here, grab Kansas City's, and come up. So yeah, a little bit of hard coding, but should be fine if we're just making a graph like this. Same thing for Rosen. We're going to want to do Rosen stats. And take Miami's color from down here and copy that in. Size equals 3, because we want these to stand out over this size equals 1.5 right there. Put our theme 538, and then do our labels. So dropback number will be on the x-axis. Cumulative EPA will be on the y-axis. Each passer's cumulative EPA 2014 through 2021. All other passers with at least 200 dropbacks in gray. So we can see what that looks like. So it'll make 3 geom smooths, one for the all these passers right here, one for Mahomes and one for Rosen. So when we open that up, we can see that Mahomes is right here, Rosen is right there. But if we were to post this graph or include it in an article or something, someone might be confused on like why those two bars are highlighted. So what we can do is we can use this annotate function, and we can say we want it to be text, because with annotate you can do a lot of things. You can do like an arrow, like pointing to something. You can do text. You can do like squares and rectangles and stuff like that if you want to show something. And then the only thing about annotate is you have to kind of mess around with the values. So I did this ahead of time. So you can just put, we want the x to be 2250, y to be 620, because that's where the coordinate on the graph is, where they are. And then we want to label it. We want that to be p.mahomes, size 5. Same thing for Rosen. Again, I looked at this ahead of time, so he had 750 dropbacks around, negative 200 cumulative EPA. And we can put our size there. And then now we can look at our new graph. I open it. Now we can see Mahomes is this red line, Rosen is this, blue green line, and then like all the other passes are right here. So this is to show that Mahomes is on a historically good pace to break all the EPA records. Rosen was on a historically bad pace, basically. And then if we if we wanted to create a scatter plot out of this, what we could do is we could use the geom point function. So like what we would have to do is we could get like each player's average EPA, and then the amount of dropbacks that they've had or something like that, and we can plot it basically. So we can just call this passers. We can take this pass, play, group by passer, summarize, get their passes and their average EPA. So we can see it's 94 passes right now because we had the 200 filter, but 94 passes is still a lot. So one of the things we can do is we can arrange, if we just want to plot 40 passers, because that should be a good enough number, with the amount of passes that they've had. We can arrange by the amount of passes, and we can use this slice head function and say n equals 40. So this will just take the top 40 quarterbacks with passes, basically. And so we can come down here and we can do our scatter plot. So we want the amount of passes on the x-axis, their average EPA on the y-axis. We can do geom point, since this is a scatter plot. Oh no, we don't have to fill it. We can just go with a gray black fill, basically. If you wanted to, you could do team abbreviation equals last. So you could get their team abbreviation and join it in or something. Actually, let's do that. Let's join it in. So we can left join the team's colors like we did earlier. This time I set it up where, I called this team abbreviation in the summarize. So all we have to do is just left join by team abbreviation. We don't have to do like equals anything. And then we can, put the fill as the team color, put it as team color 2, shape equals 21, size equals, in AES, why don't we do size equals the amount of passes or something, even though we're plotting that, usually that's not something to do, but just for the purpose of showing it. And then again, we're going to go into a package that we didn't load. So we're going to go into the ggRepel package. So ggRepel : AES label equals passer, size equals 5. In 538. And I forgot to do the scale color identity. So now I can open this and I can see kind of what this plot looks like, basically. Like Mahomes, not many passes, but super high EPA. Foles, not many passes, really low EPA. And then a lot of these quarterbacks that have kind of like, they've played so long because they're good quarterbacks. So, they have pretty good EPA and stuff like that. And then, what we can go do is we want to see, okay, well, like what's the average EPA? So we can come up here and we can say, we want to create a horizontal line with a y-intercept. And so we can do that by getting, taking the mean of all these passers' average GPA. We don't want it to take up too much attention, so we'll just make it dashed. And then we'll do the same thing for the amount of passes that we have. So we'll do that. And yeah, now we have our average lines basically. So we can see that Carr slightly below average, Stafford slightly above average. Dak has thrown an average amount of passes in this data set, basically. So yeah, so that's kind of how to make a scatter plot. Since we're getting close to the end here, if anyone has questions, let me know. But yeah, this will be recorded and posted on YouTube. Sorry again about the recording thing in the middle. I didn't realize my computer was so low on space. So we should be able to put those two together and upload it. And then yeah, just reach out if you have any questions.
Before you go real quick, what does the $sign do? What is the significance?
Oh yeah, sorry, I should have explained that. So what the $sign does is it gets the columns inside the data set. It's like if we were just to do mean average EPA here, like it wouldn't know like what where average EPA is coming from really. So it'll just say like error in mean average EPA not found. So instead, if we were to do passers $sign to get into that, we can see like we have all the columns in the data set. So now we can get like an average EPA.
Perfect. Thank you.
Yeah, of course. Cool.